Welcome back to this video wherein we are answering some exercises relating to simple harmonic motion. So let's get started. The second problem is the kinetic energy versus displacement for a system undergoing simple harmonic motion is shown in the graph. The system consists of a 0.125 kilogram mass on a spring. So we have here displacement, we have here as the kinetic energy. So imagine that we have here as the amplitude, and it's changing the kinetic energy at different positions. You notice that here at the equilibrium position, it is having a maximum kinetic energy. Determine the maximum velocity of the mass. So how do we determine that? Of course, we know that the formula for kinetic energy is equal to 1/2 mv squared. Since we know that the maximum kinetic energy here is 4 joules, then we have 4 is equal to 1/2 times the mass, which is given as 0.125, and we can determine the velocity, which is equal to v is equal to the square root of 4 all over 1/2 times 0.125, so the answer is 8 meters per second. How about for the next question? Sketch the potential energy and determine the total energy of the system. We know that the potential energy and the kinetic energy is equal to the total energy, and we know that the conservation of energy, which means that energy cannot be created nor destroyed, it just changes from one form to another. So the solution here is, since we know that 4 joules is the kinetic energy here, then that means that 4 joules is the 4 joules also is the potential energy here at the maximum positions for the amplitude. So the potential energy will be inverted graph for the kinetic energy, which is given like this. Okay, so just a quick review. For example, this is 0 joules, 0 plus 4, then we have 4 joules. Here we have 2 joules plus 2 joules, then we still have 4 joules. We have 4 plus 0, we have 4 joules. So we know that the total energy is not changing, it's just constant. What is changing is just the potential energy and kinetic energy depending on the position. This is what I have been saying. Determine the spring constant of the spring. We know that there is a formula here which is equal to potential energy is equal to 1/2 kx squared. We're given the maximum potential energy and we have already the mass, but we don't know the k. What is the x now? The x is the amplitude, which is 2 centimeters. Thus, we will have 1/2 kx squared. So 4 is equal to 1/2 times k times 0.020 squared. So the answer is 20,000 newtons per meter. Determine the acceleration at x of the mass at x at 1 centimeter. So what is the acceleration at 1 centimeter? From the Hooke's law, we know that F is equal to negative kx. This is the formula in the previous video. And since we already have the k and we already have the x, then we can determine the force, which is negative 200 newtons. You notice that this is positive. Remember that this is directly proportional to the negative of displacement. So if this is here, that means that the restoring force is to the left. That means that it's negative because it wants to go to the equilibrium position. And since we know that F is equal to ma, and we have the mass, then we can determine this by negative 200 is equal to 0.125 a. So the answer is acceleration is equal to negative 1,600 meters per second squared. Again, this is negative because for the simple harmonic motion, acceleration is directly proportional to the negative of displacement. And we are going to continue this exercises in the next video. I hope you tune in. Okay, have a great day.